today I'm going to do surds. We've looked at surds already, so I'm using your textbook. Now, some of you might have already looked at this, but I'm going to be looking at pages 9, 10, and 11 from the textbook. I will photograph after the Zoom these 3 pages, 9, 10, and 11, so that if you can't find your textbook, at least you will have it as a photograph. Okay, so what I'm going to do, let's go back to simplifying surds. No calculator, and let's really try not to use the calculator. Okay, let's go back to one of their words examples. If they have done it, but I'd like to just show you again, just quickly, how I would do something like this. So, as you know, you can collect like surds, but at this point in time, none of these are like surds. You can't add or subtract them. However, the aim, I've told you this before, is to always try and get a prime number. Now remember, 1 is not a prime number. Prime numbers are numbers that only have 2 factors. For example, 2, 3, 5, 7, 11, etc. times a perfect square. Remember, a perfect square is something like 0 is a perfect square, because 0 squared is 0. 1 squared is 1. So 4 is a perfect square because it's 2 squared. And 25 is a perfect square because it's 5 squared. And 16 is a perfect square because it's 4 squared, right? So what I suggest you do is, in your head or with the Casio, I suppose, okay, it's a bit noisy. Someone needs to just have that muted off there. So the surd 48, if I divide 48 by my first prime number, we've got 2, we've got 3, we've got 5, we've got 7, we've got 11, we've got 13, etc. So I'm going to get 24. Now 24 is not a perfect square. So I know it's not going to be 2 times 24. Let's see if this is divisible by 3. You know that clever trick to see if a number is divisible by 3? Just add the integers. So 4 plus 8 is what? 12. 3 can divide into 12, so 3 can divide into 48. All right, so if we just, you could use your calculator, you really could, but if you did use your calculator, excuse me. Okay, I think to make things fast, I'm just going to, it's called legal cheating. So if I go 48 divided by 3, the answer is 16. Now that's great. So in other words, look, prime number times perfect square. 3 times 16 is 48. There you have, you can't break a prime down more. It's already prime. And here, do you agree that that's going to be 3 times 9? 3 is prime and 9 is a perfect square. So then look, you can square root the perfect square. I'm going to write here. So you're going to get 4 surd 3. Now, because you've taken the square root of this number, which is in the radical, do you see if you square root 16, it's 4. But the 4 must be out the radical because you've square rooted inside the factor of 16. And then minus in the numerator, we have 1 surd 3. And again, the square root of 9, being a perfect square, becomes 3. But the surd 3 must stay. Then you add them or subtract, and you say, okay, 4 apples minus 1 apple. We have 3 apples, and it's divided by 3 apples. So this actually cancels ones. This 3 divides there ones. 1 over 1. Final answer is 1. So theoretically, I think I've told you this before, I can show you a trick. Mrs. Holmboe is full of magic, okay? No, not that I'm a witch or anything. But you remember my class Expelliarmus, okay? I'll give you a magic trick, if I haven't already, where you can cheat with your Casio legally, totally legally, but they would never know, okay? I don't believe in cheating, but if they say simplify no calculator, that means no decimals, and you've also got to show the relevant steps. Because as we know, in trigonometry, if I gave you cos of 120 degrees, if you don't do the reduction first and say that becomes negative cos 60, which is negative a half, if you just plug that in your Casio and get negative a half, they're not going to give you the mark because it said no calculator, show steps. So very quickly, you all saw what I did there. I tried my best not to use a calculator. Okay, I just cheated and just wanted to see what 48 divided by 3 was because I was too lazy to do it. But remember, if you do your NBTs next year, there's no calculator, so you got to know how to do this. But I'm going to do the exact same thing, but I'm going to show you the cheating method, which is allowed. So if you just arrived on the screen, if you have just tuned in and I've shown you the cheating method, it's legal cheating. I do not believe in cheating, but what you could do is you write down the question. So it's the square root of 48 minus the square root of 3 over the square root of 27 equals, leave the second line for now and go into the third line. So if you, on your Casio, as long as you're in the right mode, well, what is the square root of 48? Then the square root of 48, now we're writing in our third lines. The first line we leave in blank, so we're writing in our second line. That was the question. So leave the first line blank. So your Casio always gives it to you in simplest third form, okay? And then downstairs, you could just say, what is the square root of 27? Okay, so your Casio say 3 third 3. Now going backwards, because they want to see that step, you take the number on the outside, and if you square it, you just put it inside. So now I know, that is 3 times 4 squared is 16. Minus 3, take the number on the outside. If you squared it, it's 9. So now I know that that is the prime number 3 times 9. So 3 third 3 over 3 third 3. We still left with 1. But now if you were a teacher, you would have had no clue at all that I did not use a calculator. So I kind of went with my calculator, then came backwards, and then came to the answer. Okay, so yeah, but also, do know how to do it without a calculator because, as I say, I've told you this story. My class, I'm sure I told this story too, maybe at extra maths, but my own daughter in a matric prelims, thank goodness not the finals, but prelims, her calculator died. And she turned it off and she did everything she could. And the last 10 minutes, she turned it back on and there was a little bit of battery and she just finished off certain sums. She was actually, I was very proud of her because she didn't panic. I know a lot of you guys, you don't even know what 25 divided by 5 is. So, you've got to learn to also, when you're doing your homework, try not to use your calculator, use your brain. All right. If I have a look at another example, let's just look at their number 4. Okay, now I know they've done it as a learning channel. Let's see how I do it, and then let's see how they did it. Okay. I'm not even going to look at their method. I'm just writing down the question. Because they've actually, funny enough, given 2 ways you could do it. Method 1 or method 2, here or here. But I don't want to look yet. The main thing is hopefully I get the same answer. And if I get the same answer, then maybe I've invented maybe. I'm not sure. But you see, this is the square root. All right? So we can square root 4. So that is 2. But now we've square rooted it so it's on the outside. And remember, when you're taking the radical and you want to get rid of it, you divide the exponent. So that would be x to the 9 over 2. I think I'm going to try this method, see where I go. Minus. That's what I would do. Okay? Then the square root of 16 is 4. X to the, remember, divide the exponent. So I get 3 over 2. Remember, that is exponent of 1. That's a square root. So in the denominator, I've got x to the fractional exponent of a half. Now, first of all, I notice 9 over 2, 3 over 2. So I'm just having a look quickly. Remember, don't square root it or anything, just hold on. I could definitely take 2 out as a common factor. And then I've got, okay, I see where we're going, I think. I think I see where we're going. Let me see. So now we take out the 2. We could probably take out x to the x to the 3 over 2 plus 6 over 2 is 9 over 2, because you're adding the exponent. Times x to the 3 over 2 times x 3, x is 3, minus 2. Can you still see, or is it because, let me just see. Yeah, you can see the bottom. Okay. Just got to finish it before I answer questions. There might be a very easier way to do this. I don't want to look yet, because then I spoil my fun. So just hold on a seckie. We've got something times something, bracket times something. So remember, if you have the basis and you divide, you subtract the exponents. So I want to, sorry, I'm now from I'm planning the way I write this very well today. I should start then. But anyway, so let's just see what happens. We've got 2x cubed minus 2. Don't worry, I know I've left the x out. Hold on. Sorry. There's the 2. Now, we're going to take x. We're going to take the original exponent up in the numerator, which is 3 over 2. But we're going to subtract the bottom one, which is 1 over 2. And then just so you know, I'm left with the ghost 1. So what does that become? Okay, I should have put it equal. So it's 2. So that becomes x. So 3 over 2 minus 1 over 2 leaves me 2 over 2. Ha-ha! And 2 over 2 is 1. And I want to see if this is what they got. Because, they got a very different, wait. Am I looking at the right thing? Okay, hold on a tickle. Hold on a tickle. This is interesting. I've either made a mistake, which I could have. See if they did it like me. Okay, let's go back to the drawing board and find where my mistake is, because their answer is totally different. So you have witnessed a big mistake. But let me see, maybe I copied the question down wrong. So we've got 4x to the 9 minus, oh, there it is. Inside the square root, we've got 16x. You're never going to believe this. I copied the question down wrong because that should have been a 9. That is very, very irritating. So listen, that is the right answer, unfortunately, for what I did. I can see that that should have been a 9. I don't know how I wrote a 3. Sometimes don't you make careless errors and you think, how could I have thought that that was a 3? It should have been, that should have been the question. And if the question is different, the answer is different. But guys, my method was fine. They do it 2 methods here. So you can check out how they do it. Okay, but it's going to work. It would work much better. I mean, I can already see. I'm so tempted to do this again because it's going to be so much easier with that big x to the 9. But anyways, it doesn't matter. I don't want to waste your time. Let's just move on. If you still don't understand that, let me know. Let's just go on to, I want to show you FOIL.
Ma'am, you,
Yeah, I'm listening.
your screen, it's kind of portrait mode. I don't know. Does that make sense?
Say again?
It's kind of portrait mode, so it's like I have to turn the laptop screen to be able to see it.
Seriously, but my screen shows horizontal like always. Nothing's changed. Why do you think that's happened suddenly? Because if I look at the back of my phone, there's my hand. I'm seeing exactly what I'm seeing. Let me see the camera. Yeah, I'm not doing anything I don't normally do. That's very weird. You sure it's not your phone?
I'm not sure. Oh, it's okay. Maybe
Yeah, it's everybody's, but people are saying that
it's also my phone.
It's the only problem is that it's gonna affect the recording.
Are you saying I must do that?
Yes.
Saying I must do this? Okay, I don't know if I can do it like that because of my tripod.
Just for now, ma'am, because it's gonna record weird, and the people are gonna have to change this, like turn their screens when they watch the recording. So that's right.
So you saying that?
There we go.
You
it's
turn
right
your head. Sorry, just quickly say, what should I do?
It's right again, ma'am. The way you. Okay. There we go.
Is that right?
Yeah, keep it like that.
Yes.
So that's how that's how I had it, chickens. So what?
Yeah, but there was a problem.
And trickery happened here. Now I've got to put it back on.
Sorry, ma'am.
I had it like that. So we're back in a full circle.
It's Nelly's fault, ma'am.
Is it Nelly's fault?
Yeah, yes. Of course, all the time. Well, you know, all the time.
We want every lesson must be unique. So to prove that we have not recorded this and we didn't make it perfect, because no one is perfect, and even your teacher copied the question down wrong, it's fine if the camera goes upside down, and now we're going to be back. Ta-da! Sorry, I have to laugh. Errors happen. I didn't even turn on my light. I normally do this. I don't know. Is that brighter? I forgot to even do that today. Or do you not see a difference at all?
There's no difference, ma'am. Save electricity.
Okay, now we're going to do foil with certs. Okay? So let's say I go to your textbook and I go to exercise 5, number R. Okay? Now I'm going to do it. It goes simplify, no calculator, and it gives me 5 cert 2 minus cert 3 squared. Now, a binomial squared, you all know by now, you're grade 11. You cannot shower the power. You'll get naught. That means you have the exact bracket with the exact sign times itself. Now, I can do this in my head. But when there are certs, I think you prefer maybe for me to show you what's going on in my head. So foil, we're going to times that with that. So you times the factor 5 with 5 and you get 25. When you times cert 2 by cert 2, it just becomes 2. Let me remind you why. If you have a cert 2 times a cert 2, do you agree that is the same as the square root of 4? But being a perfect square, the square root of 4 is 2. So any cert times itself comes out. So the cert 3 times cert 3 is 3. Cert happy face. Okay, so 5 times 5 is 25. Cert 2 times cert 2 is 2. Now, minus 5 times that goes to 1 there, so that's just 5. Now you have cert 2 times cert 3. Now remember, cert 2 times cert 3 degree is 2 times 3, which is the same as cert 6, right? So I'm going to actually make that 5 cert 6. Now watch, now we've got to go minus times plus minus 1 times 5, 5. And cert 3 times cert 2, okay, that's cert 6. And to end, times a minus. What is surd 3 times surd 3? It comes out. These are like terms, all right? So we've got 25 times 2, which is 50, minus 1 apple minus another apple is minus 2 apples. But an apple is 5 surd 6, so we'll come back to that. And then I can add the 3 and the 50, so that's 50. And then lastly, if you multiply that, minus times plus is minus 2 times 5 is 10, and that is now surd 6, right? Get that right. There's an answer in front. Quickly look it up, because I'd hate to have shown you that wrong, while you try one. I'll give you an easy one. My one was harder. I'll give you Q, which is 5 minus surd 3 squared. I just want to look to see if my answer's right, lamb chops. So quickly, yeah, I'm listening.
Why did you get 50 minus 2?
I've got, do you see that is 1 minus 1 minus another 1. So we have minus 2 of these things.
Oh, okay.
I just want to check. You all do this, and I'll quickly check I did that right. I just want to find my textbook. The answers are at the back. So quickly do the second one. Oh, you have to commend me for being so clever. My answer's right. It kind of, you get the thing really stupid error there, but the answer at the back of the book, 53 minus 10 surd 6. Okay. Some of you have finished. Some of you are still doing this. I'll give you 10 seconds. Go faster. I'm going to do it the long way, not the short way. All right, guys, please remember, don't make 1 plus and minus if you get a bracket squared. A bracket squared means you've got that exact bracket times itself that. So do you understand? You keep them exactly the same. Now FOIL. So the first 5, then the outers, plus times minus is, and you get a 5 surd 3. This time you're going to get minus, and you can multiply in any order, so you get 5 surd 3. Sorry, need to borrow some space. And then lastly, minus times minus is plus, and we've done this 3 times already. Surd 3 times surd 3 is 3. Comes out. So now those integers we can collect together. So 25 plus 3 is 28. Now watch carefully. We have minus 5 rand minus another 5 rand. Do you see it's minus 10 of those things? So just think of that as minus 5x minus 5x. That would be minus 10x. So it's minus 5 of those things minus another 5 of those things. So if you add that, you get minus 10 of these guys. And you can't go further, so that would be your answer. All right? And I don't even have to check that because that was really, really easy. All right. Let's give you as hard as it would get. Let's get you to try one. And then I want to turn the page and show you the last concept working with surds is when we've got a rational I'm going to show, like to show it again, whether it's today or tomorrow, because I don't know actually how many minutes I've left. I think 8 or 9. Am I right? Anyone? 8 to 9 minutes left, I would imagine.
9 minutes, ma'am.
Okay, don't worry. Only 5.
Ma'am, I said 9.
Okay. Oh, 9. Okay, thank you. Thank you. You should have said we have 3 squared minutes left. What do you think? You should have said that. Anyways, let's give you something a little bit nasty. Okay? You can do more at home, but let's give you bracket the square root of 5 plus 2 third 3 squared minus bracket third 5 minus 2 third 3 squared. Term. I'll give you a clue. You have to do FOIL, and then you have to go minus and open a bracket and do your FOIL, and then distribute, and then collect your like terms. So you're looking at you can't hear me telling you I'm busy. It's meant to be that I'm busy doing. So you don't know what I'm doing. Right? I'll definitely check. Take that minus. He's the horrible ghost. Remember the minus. So you're going to the signs change, take the ghost away. And minus 12. Minus. Okay. Add 5 and minus. She got 4 third 15. See it? So that's 8. 8 third 15. Think. I just want to make. Right. Let's go. The textbook. Yeah. So guys, chapter 1. So you'll like to. That would be. We do as 5. That's number T. 4. Titanic. And the exercise T. And I've got to find T. 15. Oh, you're proud of. Okay, well, so right, I am the maths teacher. Notice errors. You're not sure what I do it slowly. I go by inspection. You square the first time your answer. Always positive, square the last. So you might not know how to do it by inspection. I did it maybe a bit quicker than you, but remember, if you have a minus outside of a binomial squared, you've got to keep the FOIL in a bracket, and then you times the minus first one into each of the terms to get rid of the brackets, and then you collect your like terms. Okay? Right. So now listen to me. I would suggest, you know, I mean, number V for victory, looks like a hell of a lot of fun. It doesn't actually look hard, but I would, if you want to, if you want to go back, go do the whole of exercise 5, all right, up to V for victory. Even the ones we did, you might want to do again. Then check at the back of your book. If anyone's not getting the same answer, somewhere in this room I have the teacher's guide, so I could send you a step-for-step memo if you're struggling. How many minutes have I got left? Anyone? 3.
3.
Okay. 3. 3 to the exponent of 1. Just show you what we're going to do tomorrow. This is called rationalize our denominators. A third is an irrational number because it's going to be 1,89 or 1,9 something, and then you have to round it off because it doesn't terminate. So you see, if you get like a value over a third, then you see you've got an irrational number, irrational, in the denominator. So if they want you to rationalize the denominator, I think I've shown you this before, but I'm going to show you again. Then you look at the bottom, you would times this by surd 3 over surd 3, because any, so if you times by 1, it might look different, but you're not changing its value. 4 times over 1, 3. Now you might say to me, Mrs. Third in the numerator, that's fine. It just it's in denominator, right? I might have shown you that story with the bird. Remember the bird and the third? I'll show you again tomorrow. I love it. It's got lots of blood and I made that story up, but I've got a feeling I've told you already. We get cut off. I would like you just on exercise 5 for now, and tomorrow, as hard as this gets, it gets just a little bit harder. You've got to times it by the conjugate. I'll explain what that means tomorrow. Smiling. Love you.
Bye, chicken.